Hello, and welcome to another episode of Containers from the Couch. I'm Jeremy Cowan. I'm a developer advocate at AWS, and joining me today are several folks who are going to help explain what the Observability Accelerator is. You want to introduce yourself, starting with Maya?
Yeah, sure. Hello, everyone. Hi, Jeremy. Thanks for having me on the session. This is always exciting. I think this is my third participation in Containers from the Couch. I've always had great experience here, and love the audience. So, my name is Imaya, and I'm a principal solution architect. I focus on observability. Nice meeting you all, and looking forward to the session.
Great. Vikram, you want to introduce yourself?
Sure. Hey, thanks, Jeremy. Thanks for having me. My name is Vikram. I'm a principal technical account manager based out of Vernon, Virginia, serving our enterprise support customers. And I also focus on observability and container services.
Awesome. And Rodrigue?
Yeah, hi everyone. My name is Rodrigue. I'm a specialist solution architect. I'm based in sunny Paris. It's very warm today, and I focus on observability in the same team as Imai.
Fantastic. And a big welcome to all of those who are joining us on the stream. If you want, you can say hello in the chat and let us know where you're joining us from. So as I said at the beginning, today we're going to be talking about the Observability Accelerator. And before we get to that, I just wanted to quickly talk about EKS blueprints because it is related to the discussion we'll be having today. So EKS blueprints is a way for you to quickly bootstrap a cluster with a variety of different add-ons. And the accelerator integrates with that, and Vikram, Maya, and Rodrigue are going to explain how it's integrated. The other thing I wanted to quickly introduce here was that once you have a cluster running, there may be a variety of things that you need to do before you run your first workload on it. And that includes installing software that is going to help you monitor the workloads within your cluster. And EKS offers a variety of add-ons. Recently, we published the OTel operator as an add-on, which, if you're not familiar with operators, an operator is basically a way for you to codify best practices for lifecycle operations, from the installation of software to upgrading that software, backups if it's applicable, and so on. And so the OTel operator installs the ADOT agent and helps you configure that agent for monitoring workloads within your cluster. And so with that backdrop, I thought I would hand the baton to Maya to talk about the Observability Accelerator and how that is going to help customers monitor the workloads within their cluster.
Absolutely. Thank you, Jeremy. So I'm going to share my screen. I don't know if my screen is already shared or not. Thank you. So I'm on the Observability Workshop homepage. If you want to get there, all you have to do is go to observability.workshop.aws, and you will get here. It will redirect you to this URL, though, but you will get here. So basically, we have different observability options that from as AWS customers. AWS offers AWS native options through CloudWatch, X-Ray, and Service Lens, and all that. And also we have open source managed services through Amazon Managed Service of Prometheus, Amazon Managed Grafana, and Amazon OpenSearch, and all that. So customers can pick and choose the particular feature or the service that they actually like in terms of setting up monitoring for their environment. So it's not this or that sort of a thing. You can actually pick pick and choose what you like. For example, if you want Lambda Insights, because Lambda Insights has advanced monitoring for Lambda applications, you can that comes with out-of-box dashboards and collects additional metrics for Lambda functions and so on. You can still use it, but if you are using other services, say for example like Managed Prometheus service, and because of it now you want to consolidate all that information into one dashboard, you can use Amazon Managed Grafana to visualize all the stuff. Like when I say all the stuff, I mean metrics from CloudWatch, log from CloudWatch, or even open source data and managed search for Prometheus and all of that together in one single dashboard. Or even better, you can actually visualize all the data into just one single panel within a dashboard in Grafana itself. It makes it super easy. So customers have lots of options to choose from. And I want to take down the memory lane a little bit, particularly to Container Insights. I think that was my first container from the couch session that I actually did when we did the Container Insights feature. So if you remember, Container Insights is a feature that is built within CloudWatch that allows you to set up observability or monitoring. I'm specifically talking about collecting metrics and logs from all the different resources. It could be an ECS cluster or an EKS cluster. You could set up data collection really simply by simply checking a checkbox for ECS, for example. And for EKS, we had a simple quick start approach that we did, where we supplied you the kubectl command and all the configurations, which you could simply run one line of command, and you could basically collect all the metrics and logs from your clusters, right? So it would automatically deploy a CloudWatch agent, or you can also now, you can actually use a ADOT Helm chart, which is the AWS distro for OpenTelemetry Collector, to deploy to your cluster also to collect metrics from that environment. And also it would automatically deploy the FluentBit agent to collect logs and all that. And it would send to the CloudWatch service, and it would, within the CloudWatch service, you got a Container Insights console. You can see all that, all the dashboards. I'll walk you through them in a little bit, which makes it super easy. So I'm on the CloudWatch console in the Container Insights. It's under the Insights section here at the bottom left. And here I have a few clusters on which I have enabled Container Insights, ECS, and I have both ECS and EKS clusters. I can go to any of them. I have, I'll just go to one of the EKS clusters. I think I have my session expired, I guess. Maybe it'll take just a few more seconds. I can go to any cluster, or maybe let me go to the ECS console meanwhile. You can super easily enable Container Insights by simply clicking on a checkbox saying enable Container Insights. So that easy. So what we thought is, when we were working on when we launched the Managed Prometheus Managed Grafana, we wanted to make it as easy like that. So we wanted to make it super easy for customers to set up observability on their environments. So if you look at in Container Insights, not only on EKS clusters and ECS clusters, but we actually have specific workloads on which you can enable monitoring. Say, for example, EKS HA proxy workload. So HA proxy workload, I have a sample workload that is running, and you can see that I have deployed HA proxy, and I've deployed the CloudWatch Prometheus agent. It basically collects metrics using on a Prometheus endpoint and sent to CloudWatch. And the dashboards are out of the box, and I have similarly built dashboards for other workloads like Java, JMX, and all that, which makes it really easy. I don't have a workload here, but that's why it's empty. But you can imagine all the different workloads that are popular have dashboards that makes it super easy for customers to set up observability on their environment. So
now, Maya, I have a quick question for you. So for you to get those metrics, did you have to instrument your application, or are these default metrics that that this web server exposes?
Great question. So if you have Java workloads, there's this Java JMX exporter that would actually expose metrics in Prometheus format. And Nginx has Prometheus exporter as well. So you can have an Nginx make Nginx export Prometheus metrics automatically, and it would expose metrics at an endpoint. So what in containers says what happens is you can either deploy the OpenTelemetry collector or the CloudWatch agent in with that configuration, and it will use the Kubernetes service discovery to find the endpoints based on the job script configuration that you have in your agent, and it will read the metrics and send to CloudWatch. That's what happens in CloudWatch. It happens through a technique called EMF, or embedded metric format, where it sends metrics in the form of logs, and CloudWatch extracts those metrics into CloudWatch metrics. So that's how it works. So it not only has to be that, it can also be custom application metrics because it is configurable. You can always have the script configured in such a way that your agent goes and reaches out to your custom endpoints, and it could be custom application metrics, something like how much latency, what was the latency in making a particular API call, or what kind of searches are being performed and stuff like that, right? Like customer visits and stuff. Any custom metric. All you have to do is use the one of the Prometheus SDKs that is available for all these languages, and you just have to instrument, which is really straightforward. And again, we do that in the observability workshop. You can actually go there and actually find out in the source code on how we do it for different languages like Java, C#, and Go, and so on. So our idea was to bring that experience to, going back to this, bring this experience to Managed Prometheus Grafana, right? So today, if you go to the Managed Prometheus setup, there are a few steps that you have to manually sort of configure, right? So you have to deploy the collector, you have to have configuration for that, and you have to create the Managed Prometheus workspace. You have to have permission set up. You need to create a dashboard for all of that. Again, this may not be sounding that difficult if you do it once, but if you did it many times for many environments, then it becomes a task, right? So that you want to automate. This is also error prone. And how would you also maintain it, right? So what about the knowledge gained with this? So that becomes a little bit of a challenge. Although the newly launched AWS distro for OpenTelemetry operator, or the ADAR operator, which basically operates, like you mentioned, Jeremy, in the beginning, which basically manages the lifecycle of the ADAR collector, which is an agent that collects metrics and traces at the moment from different environments. So although it makes it a little bit easy, the operator is also available as an EKS add-on today. You can simply just go and enable it from the console and start deploying. But you still have to go through those manual steps, which can be automated. So that's when we thought about, okay, so why not make this experience look like CloudWatch Container Insights, to make it really easy for customers to deploy and collect metrics. So that's when we got the idea, and we started exploring the EKS blueprint, which was a project that the containers, the EKS team was building, and we thought that would be a perfect place to put our package in, so customers can make use of it quickly.
Nice. So, are you going to show us a demonstration of this working?
Yeah, absolutely. I want to invite either Vikram or Rodrigue to take over and demo demo what we want to show.
Yeah, sure. I can do that. I can certainly do that. Let me share my screen, maybe. Yes. So tell me when you're able to see my screen.
Yep, we can see it now.
Yeah. So the project that Imaya was talking about is on GitHub. I can send you the link. You find the link in the chat. But basically, this is the EKS blueprint. I believe there was a session, a previous session on containers on the couch where the folks explain this project. I'm gonna basically show how we hooked into that quickly, how it works. Basically, those are collections of examples built out of modules. So it's an open source project. Obviously, you can use the modules, reuse them, reassemble them yourself for your environments. But we have published a lot of examples that are based out of real life situations. In our case, the Container Insights experience, and they are all wrapped into the observability group. So we have deployed HA proxy, Java Memcache, and Nginx, and out of those, so today we'll take, for example, Java. Out of those, you will find dashboards. You will find alerting rule on Prometheus. You will deploy the entire thing. And I want to quickly maybe show you a mental model of how this works. Basically, all the observability stuff are going to be under example observability, and then you take the workload that match your use case. You can obviously compose your own as well. And by the way, if that's great, you can send a PR. We can take a look at that as well. So what you're gonna have is you're gonna use a Terraform module to create the VPC. Use the blueprint module. So the blueprint module is all the tested stuff that we have built to create the EKS cluster, add the necessary add-ons and all that. Under the add-ons, this is where you will enable these behaviors, and you're gonna also have Grafana data sources and dashboards. You can use Amazon Managed Grafana, which is a service that we provide, or you can use your own as well. We will propose you also set of alerts. So the idea is you can start like from scratch, from zero to something that works from end to end, and then you can start focusing on your applications and the resources that they get deployed. As I said, the VPC, the cluster, the Prometheus workspace. Today we don't propose a Grafana workspace, but this is something that we're gonna do after. And the middle piece is actually the AWS distro for OpenTelemetry add-on for EKS that will collect the data with a collector and then send the data to manage Prometheus, and you can visualize all that with Grafana. So I hope this helped understand a little bit, but let's actually go to the console.
Hey, Rodrigo, I had a quick question. So earlier, Maya showed how Container Insights had pre-built dashboards for things like Nginx and the JVM. Do we have similar sorts of dashboards for Grafana? Either
Exactly.
that folks can import, or that will be part of the solution in the future?
Yeah, that's the whole point. Like we're gonna see after at the end. I think Vikram gonna work through that. But basically, you will have dashboards with the data that you're going to. So the your application will run. The collector will take the data, and then we have pre-built dashboards as Container Insights.
Great.
So as I said, so you're gonna be under example observability. So let's take Java, for example. Yes. So I have cheated a little bit because we want to save time. So I have created the Kubernetes cluster already, but I haven't created the observability patterns. But so let's see how this looks like. So this is the example with bunch of stuff. If you're familiar with Terraform, this is just initialization. This is where you will have the blueprint with the node groups, the configuration for your cluster, and this is where you enable. With this, you will have a Prometheus workspace on AWS, and with the add-on, this is where you're gonna add stuff to your cluster. With which I have the OpenTelemetry operator, which I will enable, and the ADAT collector for Java, which I will enable as well. So basically, that is what you're gonna do. If you go on the GitHub repo, this is already enabled. I just saved time a little bit. And then forward, we'll create the Grafana data sources, the dashboards, and the alerting rules. So this is not hidden. You can see what we provide, so you can obviously tweak it for your use case as well. So let's actually deploy that.
Okay, and as that's being deployed, I see you extended the Terraform blueprint to have support for this accelerator. Are you planning to do similar work on the CloudFormation CDK side?
So yeah, I think this is something we're gonna look at. For now, it's not done, but this is something we're gonna look at.
Okay, be great to get feedback from the audience whether that would be of interest.
Yeah, so it will create. So just as a quick step back. So there is a lot of stuff, but basically we'll create a namespace for the collector, deploy the manage add-on. We will propose also in the future a way to have either the manage add-on or a self-manage add-on. I don't think it matters at this point very much, but we want to provide all options, right? So we will be able to see in the EKS console what is it actually, and bunch of permissions. So we deploy all those permissions for you, so you don't have to wrap your head around that, and all the configuration for collecting the application, sending the data to manage Prometheus, and all that. I think it is still creating. So right now it is the certificates that gets that is being deployed. Um, and yeah, so I think it's gonna be a few minutes, maybe 1 minute again, 1 minute more, and also what I wanted to show is yeah, so we visited the permissions. So this will deploy first the operator and then the application, the collector, and we're gonna after that we're gonna use a sample application that generates some data, so you can see the data being collected real time, and after that Vikram's gonna dive into the what we actually collect. So I think this is so I pray to the demo gods. Normally everything works. But yeah, so now the certificate is done. So now we're moving to the edit operator. But basically, if I open my console, um, you will be able to see if I go on EKS. I have this cluster, and you will be able to see the add-on being being created. Yeah.
Jeremy, you're on mute when you're talking.
But yeah, so Rodrigue, if you could click back on the console
Sure.
onto the resources tab. Can we see what's been deployed so far?
Yeah, sorry. So yeah, you have bunch of workloads that are created, like the certificates manager. So this is necessary for ADOT. I think you can also plug your own. I'm not the EKS expert here, but you can have a way to deal with certificates. This is certificate manager that we provide by default. And yeah, so as we go, you're gonna see other pods appearing here. Um, so here you can see the open telemetry operator being created actually. So so while we were talking, everything was done. So let's go back and see on the add-on. Uh, Let me refresh this page. So yeah, it is active. So if we go back to the resources, we can see the data collector running. If we go to the deployment, you can see the operator controller also running. So what we're going to do now, so right now we are ready to instrument applications, right? And now we're gonna collect, we're gonna deploy an application that is actually a Java application for which we can have the data. But so let me go to the, sorry, is, so there is a sample application. Um, this sample application is actually documented on the README for the example, so you can actually reuse this application. But I guess if you deploy that, you have real life application that you want to use. So we have prepare this GMX sample. And if we take a look at this, so this is basically a deployment that we are going to do. Yeah, so I'm going to deploy the application. And while this is deploying, I'm going to quickly go back to Grafana. And if we go to the data sources, you'll be able to see, sorry, the data sources. Yeah, so we have deployed this so the whole Terraform deployment created this managed Prometheus workspace, so we can actually have a way to collect the data. And if we go to the dashboards, you will see the if we go to browse, there is a folder observability, and this folder with the data. So you have these dashboards with a bunch of stuff. Vikram's gonna jump into that, but basically we collect a lot of data and we try to present it in a meaningful way for customers.
Great. And so I see that you're collecting metrics for this particular workload. We know that observability consists of metrics, traces, logs, and also profiling.
Yeah.
That's a new addition. I'm wondering what the plans are for adding those pieces to this solution. And this question is for any of you. But,
Yeah, I can give some of the answer, but you're totally right. So we are currently focusing on metrics for many reasons, right? So on the tracing part, there is not much that we have to do basically to enable tracing. However, customers have to instrument the application to have like really meaningful information. We can also auto instrument the application. It depends on the workloads. It depends, but my point is this is not as straightforward, but obviously we can take some feedbacks and see how to improve that. And for the logs, I think there are multiple approaches to take. Right now, the open telemetry doesn't support logs on production. So this is something we currently we don't support as well. But we'll see how this evolve, and obviously we can try to have that in as well.
Just to give some more insights onto that, I agree with Rodrigue. We're also trying to see, how to get customer feedback, and this audience would be a great group to provide the feedback on like what they would expect us to do in the future. But immediately what we have in the backlog is to support more infrastructure metric collection, and then additional dashboards that are specific to caters to infrastructure related observability. So that is something that's in the works. And we also plan to support more such workloads, not only these 4 workloads that we currently have. We know that these are the most popular workloads that are out there, but we also see that customers would like to see others as well. So we'll be working on that as well. So those are the 2 things that is in the mix. But tracing is something, as from like Rodrigo mentioned, from collector's perspective, the configuration is not as complex as metric collection. So it's pretty simple, but it's all about instrumentation and also maybe injecting out instrumentation into the application. So if there is a way, if we find that to be something that's doable, we certainly can take that up as well.
Yeah. So we got this question from Cloud Surfer 22 about whether this is a replacement for X-ray. Can you speak to that?
Sure. So this is definitely not X-ray. X-ray is actually a tracing service. It collects traces. So here, what we're doing is we're essentially collecting metrics. Metrics from applications, metrics from infrastructure, metrics from your environment, right? So that is essentially, to be specific, it's something like, imagine like CPU utilization, memory utilization, network traffic and stuff like that. When you're talking about tracing X-ray, you're talking about tracing, which is service to service interaction, HTTP calls, the service map, and latency and stuff like that. So that's something we can do very easily. We can easily create a pipeline. It's called a pipeline. It's basically YAML configuration, the ADOT collector. We can actually have that in the pipeline, and we can do it very quickly. But it is just that your application has to expose those traces.
Yeah.
And essentially, it is really not a complex problem to solve. So we kind of deprioritized it. But if that is something that is of interest, then we will certainly add that. But to your question, it is not a replacement for X-ray.
Okay.
And at the end, like I can even add something to that. At the end, if we have traces supported, this is X-ray you're going to use to actually have those traces data.
Oh, so the traces can be sent to X-ray then?
To X-ray, yeah. So the metrics to manage Prometheus and the traces to X-ray.
Yeah, and you could use Grafana to visualize all of them together, like I mentioned.
Yeah.
So Grafana can even visualize service maps and even individual traces and segments and this whole segment timeline. So it's pretty nice.
Yeah. So yeah, this is really cool. So in the same Grafana dashboard, you can have all those kind of data together.
Nice. Okay, let's continue with the demo.
Yeah.
What's
so
next?
I think at this point, I'm all done. I'm gonna pass the mic to Vikram to show the rest.
Okay.
Thank you, Roderick. Let me know once you guys can see my screen.
Yep.
Perfect. So I'm going to give a quick summary of what was done when Roderick fired the Terraform apply command. We're going to do a quick walkthrough of the component that got deployed as a result of the command, right? So first and foremost, like Roderick mentioned, it creates the cluster. So we have a cluster called a.amp-grafana for Java. You can see under the compute section, manage node group got created. And the important thing is add-on customers don't have to manage the lifecycle of a dot operator outside the EKS cluster. They can just infuse everything into the Terraform module and they can have it deployed. That's on the EKS side, and it also creates an Amazon managed service for Prometheus. Again, it's you can just enable the parameter within the Terraform module that's going to simply deploy a Amazon managed service for Prometheus workspace. Another important thing to note here is if you're a customer who's already using Alert Manager and recording rules, you can just customize the Terraform module to add your recording rules and Alert Manager configuration. As you can see here, we also provide a kind of opinionated recording rules config here. In this case, we are looking at the JVM memory usage, and then we are setting up an alert if the utilization exceeds 80%. Alternatively, you can extend this by adding an alert manager config where you can send these notifications to SNS receiver. So Amazon managed service for Prometheus right now supports SNS receiver. So any recording rules, any alerts that needs to be sent to can be sent using SNS. So this is on the Amazon Managed Service for Prometheus side. And finally, we also have the Grafana dashboard creator, right? So in this particular use case, we assume that we already have a Amazon Managed Grafana workspace. And what we do here is we are configuring the data source by default. So the moment you run the Terraform module, we'll be creating the Amazon Managed Service for Prometheus as a data source here. It's the same data source. It's the same workspace that gets created, that which I showed in a minute back. So we create a data source here. We also create a separate folder within the workspace. Um So we create an observability folder, and if you go inside the observability folder, we have a specific dashboard that gets created that is configured to extract JVM metrics. So if you're someone who's new to observability and don't know how to customize your configuration, like let's say you have a Java application and you would want to collect the metrics of this Java application and visually transform them on a Grafana dashboard, then EKS Observability Accelerator is like a one-stop shop where you simply download the modules and you run the Terraform module, and you get an end-to-end solution, right? From creating the EKS cluster, collecting these metrics, and then analyzing them on Amazon Managed Grafana dashboard. Uh,
So,
okay,
Vikram, not to put you on the spot there here, but do you want to show how the Terraform module is communicating with Grafana to deploy the dashboard and
yeah,
how it's
absolutely. Yeah, we can
authenticating
do
itself?
that. So I'm in the EKS Observability Accelerator Git page, and you look at the main Terraform file. So this is where we configure the data source. So we create a resource called Grafana data source with the name Prometheus, and the URL that we are configuring there is nothing but the Prometheus workspace endpoint that gets created as a result of deploying this Terraform module. And these are some of the parameters that we configure within the data source, like Grafana does a pull to kind of collect the metrics and transform them into on a dashboard. So we have the appropriate methods, and it requires SIGB for authentication. So your the data that gets transferred to the Grafana is secure, and it uses the workspace IAM role. So when you so there's just one caveat. The Grafana workspace that you have created should have the data source, like it should have the proper permissions to connect to Amazon Managed Service for Prometheus. Uh, what I'm trying to convey here is, so when you go to your Amazon Managed Grafana workspace, under the data source section, make sure you add the permissions for Amazon Managed Service for Prometheus. So it's an important permission to have. It kind of gives permission for Grafana to connect with Amazon Prometheus workspace and pull the metrics out of it and transform that into a dashboard. So make sure you have these permissions enabled on the Grafana workspace.
Could you show the token that is used to authenticate to Grafana to deploy the dashboard?
Yeah, sure. Uh, y- you mean the API keys, Imaya?
Yeah, yeah, that's right.
Okay, okay. Another thing is, okay, let me. So in order for for Terraform to connect with Grafana and create these, like I mentioned earlier, um, the Terraform module was able to create a folder. It was called observability, and it was able to create a dashboard inside that, and it was also able to configure an Amazon Managed Service of Prometheus. So Terraform needs certain permissions to kind of connect, make API calls to this Grafana workspace, and do all the operations that I just mentioned. So for that, what we do is we create an API key within the Grafana workspace, and we configure this API keys into the Terraform module in the variables section. Let me quickly show that. So again, we are in the Git, the main page where we have the use case for deploying or running observability solution for Java workload. So if you go dive deep into the variables, or if you open the variables file, so here we configure the Grafana API key. So this is really important for Terraform to connect with the Grafana workspace and create the data source configuration and also the dashboard configuration. And we also specify the endpoint, Grafana workspace endpoint. So make sure you configure these two variables for the end-to-end working of the solution.
Right. We may want to delete the API key on the Grafana console right away. Just to add on that, right? So today, that Grafana workspace needs to exist already, and we will be able to provision the dashboard and the data source and all of that. What we're trying to do is another addition that we plan to do, as I think Rodrigo mentioned in the beginning, is to automate the whole process as an optional step. Customers could say, someone who's deploying could say, if they want to create a Grafana workspace, they could optionally have the accelerator created for them, or they can actually make use of an existing one. It can actually make use of an existing one that they already have by providing it. So that's what is in the progress.
Okay, but today, with today's version of the accelerator, you have to create the Grafana workspace beforehand and create the API key, extract it, and put it into the Terraform values file.
Yes.
That's right.
Yeah. Okay. Great.
And just to add a couple more things, we also have a test Java application running, like Roderick mentioned earlier. We have a Java a Tomcat application running on the Java JMX namespace. What's important to note is for ADOT to scrape these JVM related metrics, it has to be configured in a way. There should be scrape config that can understand, that can collect the so-called JVM metrics, and then it can send it to the Amazon Managed Service for Prometheus. So with this particular EKS Observability Accelerator, customers don't have to configure anything on top of it, because we've already configured the scrape config, and it gets deployed along with the Terraform module. So let me show that real quick. So it should be the namespace. Let me go to
Well, it's a demo. We expect that, so don't worry about it.
yeah. Describe config map. It should be fn namespace. Should work now. There you go. So like I mentioned earlier, we have the scrape config for getting the JMX related JVM metrics. It's already configured. And what's important to note is we also configure the remote write endpoint automatically into the config map. So you just pick the modules, deploy that using Terraform, and you start observing your applications right off the bat. And yeah, once this is stored in Amazon Managed Service or Prometheus, we we have the readily built dashboard here, and you can further extend this solution by configuring alerts here. So you can always configure alerts on the Grafana dashboard. You can uh, in the alert section, you can create your own notification channels, uh, create your own alert rules, and send notifications to different notification channels. Like Slack is one of them. You have SNS, Ops Genie, PagerDuty, VictorOps. So these are some of the channels to which you can send notifications.
So I see that you have scrape config available for 3 or 4 different types of applications. What's next for the accelerator? What other applications are you looking at supporting?
we got some interest around Python-based application and Node.js application, so which is something that we'll be working on the current, in the upcoming cycles. And like Imaya mentioned, we are also looking into collecting infrastructure metrics. So we're trying to instrumentate or have the scrape config on the A dot integrated for collecting infrastructure metrics, and have some readily available dashboards on Grafana, which the customers can use and analyze the infrastructure performance.
That'd be great. Awesome.
Yeah, we'll see also if there's enough traction around traces to see if we can have traces into the dashboards as well. Well, of course, into the scraping config and the dashboards.
Great. Vikram, was that all you had to show?
Yep, that's it from my end. Yep.
Okay. Maya, you want to bring us home? Do you have any closing remarks?
Well, I didn't prepare for any closing remarks, but yeah, I guess that was a great demo from Vikram and Rodrigo. Thanks, guys. There's been a lot of hard work put in by the team members who built this. We're really excited to get this out, but again, this is just us pushing it out just a couple of weeks ago, and we're still looking to get some feedback from users, from customers. And like we mentioned, we have some items that we're working on. We are expecting, we're hoping to improve and build more features and capabilities to this in the next few weeks and months to come.
Great. Well, thanks so much for all of you joining today. It's very informative and educational. I look forward to the next time you come on the show to tell us all about the updates that you've made to the Observability Accelerator. And I've posted a few links to additional resources. I'm actually going to post a link here to a blog that was published recently about the accelerator here to learn more about it. If you have an issue, or if you see an area that you'd like us to further develop, please file an issue in the repository, and we'll try to respond to that as quickly as we can. So once again, thanks for joining today's session, and we'll speak to you all during our next episode. Thanks so much.
Thanks, Jeremy.
Thank you.
Thanks, Jeremy. Thanks, everyone. Yeah.
Bye-bye.
Bye.